Assalamualaikum and greetings everyone. Okay, we are still on Green's theorem. Now let's look at a few examples on Green's theorem. Example A, we are asked to use Green's theorem to find work done by the force field F on a particle that travels once around the unit circles x squared plus y squared equals 1 in the anti-clockwise direction. So here we are asked to find work, but we know work is really f dot dr. So f dot dr around a closed curve C is equal to this. So what we need to do is we need to evaluate double integral over region R, where region R is the region bounded by the closed curve, and the integrand is partial q partial x minus partial p partial y. Okay, so here let's look at our region. Our region is, it says, our curve C is travel once around the circle x squared plus y squared equals 1. So here we have a circle of radius 1, centering at 0, 0. Okay, let's say this is x-axis, y-axis, and this is 1. So we have a circle of radius 1, 1, 1, negative 1, negative 1. And it says the orientation is anti-clockwise direction. Okay, so here we have a... Oh, that's wrong. It should be here. Hang on. Okay. So this is 1. Here it's negative 1. Alright, and it says the direction, okay, let me read the question again. On a particle that travels once around the unit circle x squared plus y squared equals 1 in the anti-clockwise direction. So the orientation is anti-clockwise direction. So this is our closed curve C. And as you can see from here that the closed curve C will be the boundary of our region R. So this is going to be our region R, which is bounded by the closed curve C in an anti-clockwise direction. Okay, so from here we can get what is our P and our X. So Pxy is the X component of vector field F, which is Ex minus y cubed. And Q is the y component of vector field F, which is cos y plus x cubed. Cos y plus x cubed. And we are asked to find work. So we know work is really f dot dr. But here our curve is closed curve. So from there we get Pxy dx plus Qxy dy over closed curve C. Now using the Green's theorem, this is equal to double integral partial q partial x minus partial p partial y. Integrate this over region R. So this is using Green's theorem. So instead of evaluating line integral, we're going to evaluate double integral, where the integrand is partial q partial x minus partial p partial y, and we're going to integrate that over region R. So this is the Green's theorem. All right. Okay, so if p is at ex minus y cubed, so from here we need to find partial p partial y. So differentiate p with respect to y by holding x as a constant, so we have negative 3y squared. And if q is cos y plus x cubed, we need partial q partial x. So differentiate q with respect to x, we get 3x squared. Okay, now we're going to put the integrand together here. So we have partial q partial x, which is this, minus partial p partial y, which is negative 3y squared, and we're going to integrate that over region R. So here we can factor 3 out, so I'm going to put 3 out here, and we have x squared plus y squared oh sorry, that should be dA. dA over region R. Oops, I did it again. dA over region R. Alright, so now when you look at our region, it's a circle. So here we're back to double integral. So if our region is a circle, we're going to use polar coordinates. Okay, let's use polar coordinate. So if it's polar coordinate, we cannot use x and y. X must be replaced by r cos theta, y with r sin theta. X squared plus y squared will be replaced by r squared. And dA here is r dr d theta. So we're back to double integral. Okay, now let's look at our region R and determine the upper and lower limits for R and theta. Okay, so for R, remember we measure R from the origin across our region, and you can see that it starts from the origin and it stops on the red circle. So the red circle is really this unicircle, x squared plus y squared equals 1. So this is r squared equals 1, or r is 1. So from there we can get the limits for r is from 0 to 1. And the theta, we measure theta from the positive x-axis and t-clockwise direction. It is one whole circle. So theta is going to be from 0 to 2 pi. Okay. Alright, so now let's evaluate this. So here we have 3. Now we're going to integrate with respect to r. So here we have r cubed. Integrate that, we get r to the power of 4 over 4, and then replace r with upper and lower limits. Alright, and that would be 1 over 4, so we have 3 over 4. And then integrate d theta, 0 to 2 pi, so we have 3 over 4. Theta, 0 to 2 pi, so we get 3 pi over 2. Okay, so how easy it is instead of evaluate f dot dr. Okay, so this is Green's theorem. It can only be applied on a force on an xy plane, and the curve must be simple, closed, and in an anti-clockwise direction. Okay, that is one example. How are we doing with time? Okay, I'm gonna save the next example in the next video. Thank you.